Greetings, curious minds. Welcome to Frontier Obscura, where we dive deep into the bizarre, unravel the unknown, and shine a light on the shadows of the universe. Buckle up for a journey to the edges of human knowledge. For as long as we've been conscious, humanity has been haunted by a single, inescapable truth: entropy, the universal slide from order to chaos. We see it in crumbling empires, in dying stars, and most intimately, in our own bodies. Aging feels as fundamental as gravity. But what if everything we think we know about decay is wrong? What if for some species, death by old age is not a rule but an option? Welcome to the science of biological immortality. Meet Turritopsis dohrnii, the immortal jellyfish. When faced with stress, injury, or simply old age, it can perform a biological miracle: transdifferentiation. Its cells transform, essentially hitting the rewind button on its life cycle. It's not immune to death, a predator can still eat it, but it does not die from age. Then there's the Hydra. This simple creature possesses a body dominated by stem cells that are in a state of perpetual renewal. Its telomeres, the protective caps on our chromosomes that shorten with each division, don't seem to erode. For all practical purposes, a Hydra in a safe environment shows no signs of senescence. Even lobsters exhibit a form of negligible senescence. They don't revert like the jellyfish, but they produce high levels of an enzyme called telomerase, which constantly repairs the ends of their DNA. They grow larger and more fertile until the very end, which usually comes from disease or predation, not old age. So what's their secret? The answer may lie at the most fundamental level of reality: the quantum realm. The primary cause of aging is the accumulation of DNA damage. Cosmic rays, oxidative stress, they shatter our genetic code. Our repair mechanisms are good but not perfect. Errors build up, leading to cancer, organ failure, and death. This is where quantum biology enters the picture. Scientists are investigating if these immortal organisms might be leveraging quantum effects for near-perfect repair. One theory involves quantum tunneling. In our macroscopic world, a key needs a clear path to a lock. But in the quantum world, particles can tunnel through energy barriers. It's probabilistic, not deterministic. The hypothesis is that repair enzymes in these species could use quantum effects to sample vast areas of the genome almost instantaneously, finding and fixing damage with an efficiency our bodies can't match. It's not magic, it's physics. Evolution may have selected for biological systems in these organisms that can maintain quantum coherence, a delicate state where these probabilistic effects can operate long enough to perform flawless maintenance. They are, in a sense, the ultimate quantum mechanics. Which leads to the inevitable, staggering question: if we can unravel this quantum biological trick, should we apply it to humans? The technological ambition would be to engineer our cells to mimic this repair efficiency, potentially halting or even reversing aging. From a sociological perspective, the implications are profound. Who gets access? Would it exacerbate inequality to an unimaginable degree, creating a literal immortal upper class? What would it mean for our drive, our relationships, our very purpose if the deadline of death were removed? Would we see unparalleled cultural accumulation or societal paralysis? Reproduction would have to be severely managed, challenging a core human biological imperative. The quest to understand biological immortality forces us to confront who we are. These organisms show that aging is not a universal law, but a malleable biological process. The key may lie in the spooky, counterintuitive world of quantum physics. The science is in its infancy, but the conversation must begin now. Because the question is no longer if we could potentially conquer aging, but should we?